So we learn about quadratic equations and quadratic formulas because the most obvious example in real life that these things occur is with gravity. So if you've ever been in a place where there's gravity, you've experienced a quadratic formula, a quadratic equation, and a quadratic graph. Physically. So if I take this bucket, right, and I throw it up in the air, it made a parabola as it went through the air. Anytime something goes up in the air and then comes back down, if you make a graph of how it travels, it'll make a parabola.
Wait, what if you dropped it like straight down? Is that still a parabola?
It would be part of the parabola. It would start at the vertex, and it picks up speed as it goes. It doesn't go, it's going faster at the bottom than it is right at the beginning, because it's accelerating because of gravity. Okay? What is gravity? Does anybody know what gravity's acceleration is?
Is this like physics?
This is physics, but do you know what the number is? Acceleration due to gravity is negative 9.8 meters per second squared. Okay? Where does that show up in the quadratic equation? When we look at this number here in the a value, in front of any equation that's supposed to represent what's happening, as it is here, will be half of 9.8. Okay? If you double negative 4.9, you get negative 9.8, and that's the reason. Okay? Whatever number is here is whatever the initial speed something is thrown. So the plus 50 that's there is because the initial speed of this projectile is thrown upwards with initial speed of 50 meters per second. If you threw something up with initial speed of 10 meters per second, that sounds bad, throwing something up with 10 meters per second. Okay? That would change this number. And this number by itself, that number by itself is always how high something was to begin with. Because if we make time equal to 0, everything would be 0 except for that 10. So in this situation, we're imagining someone standing on a building that's 10 meters high. Okay? They've got some sort of projectile. There they are. There's their projectile. Maybe it's a black projectile. Maybe it's an egg. They're throwing it up in the air, and it's going to land over here. As it travels through the air, it will make a parabola. Okay?
Oh, so maybe that's what it means. Mr. JR.
Mm-hmm.
When people are talking about like being sick, and
Yep.
they say like projectiles, when you're like throwing up as in it makes a rain down.
Well, yeah, it's just shooting out.
Oh.
Yes, very nice.
And then the whole part of the project in like projection. You should.
Yeah. Okay. So part A, we're going to graph some of this. First of all, if this part is our height and this part is time, as far as making a table of values go, we can start by putting in 0 for time. And just like the picture shows, when you plug in 0 for time, you start at an initial height of 10 meters. If you put in 1 second for time, and we plug that in, we get negative 4.9 plus 50 plus 10. That would equal to 55.1. So you'd have it would go way up high, quite a bit to begin with. So we would have this point, 1 comma, what did I say it was? 55.1, once you plug it in. Now we could keep doing table of values and get more and more points, and we would find that gravity slowly makes it come down, and then eventually it would come down and hit the ground. But the way that our formula is written, it would just keep going into the ground and down forever into the ground. Now that's not realistic, okay? But if we want to see what this looks like, we can go to our graphing calculator. We can go to our equation, and this is especially handy when we have graphs that are hard to see. There, start again. Negative 4.9 x squared plus 50x plus 10. Now when I hit graph on this one, most of my graph doesn't appear. Look at that. Almost looks like a line. That's because right now, our window, if you have your window set the same as mine, your window goes from minus 10 to 10 on both the x and the y. As far as our graph goes over here, we're only looking at this window. If you think of this parabola that I've drawn, do you see that all this part doesn't show up? What part am I seeing? This part right here. Okay? So if I want to see more of my graph, I go to my graphing calculator and I need to say, I need to change this window so I see more of it. The way you do that is you go to the button that says window. Okay? We're going to, again, I don't need to see the negative numbers because they don't really make sense. You can't have thrown the rock in the past. It doesn't come from the ground and hit your arm and then you throw it. So I'm going to just start from -1 just so that I can see my axes. And now I think I'll go up to, let's watch 30 seconds. I'm not sure if that's too much or too little. And obviously, we know that after 1 second, it was already at 55. So maybe it's going to go at least to 55. As my maximum for my y, I'm going to go up to 100. Maybe I start at -1 there as well. If you want to change some other things on here, these buttons that say SCL, that stands for the scale. That's how many ticky marks are on your axes. So on your y-axis, if you want it to go by tens, if I change that to 10, then each mark will be by 10. So now when I hit graph, I can see a little bit more of it. I can see from my graph that I went further than I needed to on my x-axis and not enough on my y-axis. So I might go back to my window, say, I don't need to go up to 30, maybe I'll just go up to 20. But I do need to go higher than 100. I'm going to try going to 200 and see what that looks like. I typed in the original equation that was in that question, the -4.9 x squared plus 50x plus 10. So notice, did it work? There we go, let's see. No, it's not working right now. Notice that our graph started with a y-intercept of 10. That it goes up in the air, reaches a maximum height, and then comes back down. It eventually hits the ground right here. So the question is saying, explain the significance of the intercepts. The y-intercept is when your time is equal to 0. That's where your projectile started. the x-intercept is where the projectile hits the ground. So your x-intercept is where the projectile hits the ground. So if you made h equal to 0, right, the height would equal 0 in this case, and you solved it with your quadratic formula, you could find out at what time it hit the ground. Explain the significance of the vertex. The vertex is the maximum height that the projectile gets. Now for domain and range, normally the domain of a question like a parabola is everything. We said that last class, that the domain was everything. In the context of a word problem, sometimes things don't make sense. It doesn't make sense to have negative time in this case, because before the projectile was launched, it just was standing there. So for this one, our domain only makes sense when the time is bigger than 0. So I'll write it out in words. Time has to be equal to or greater than 0, because it doesn't make sense for time to go into the negative. And less than or equal to when it hits the ground. All right, we'll finish this one up tomorrow.